And this is the 2012 AIME 2 problem 8. Here is a view of this problem. The complex numbers z and w satisfy the following systems of equations. Find the smallest value of the modulus of zw squared. Now this problem specifically is a little bit more on the calculation side, so this may be a longer video due to the fact that I'm not able to do calculations quickly on the software. But with that note, let's continue. The first thing we need to do is we're asked to find the modulus of zw squared. So we have to ask ourselves, how can we get zw? Well, one option, the first thing I thought of was, well, why not just multiply, I guess, this thing by w and this thing by z. And we do get wz's terms, but we also disrupt this nice stuff by introducing some w's and z's that we don't even know what they are. So that's probably not the best approach, and if you're not convinced, you can go around and play with that and you'll see like no progress will be made. So next thing, how do we get zw? Is we can simply multiply the thing, right? Multiply the two equations. Z plus 20i over w times w plus 12i over z. Simply multiplying them will get us a wz term. And then these conveniently cancel out as well. So this gives us wz plus 12i plus 20i, and then this becomes 240i squared, so negative 240 over wz. Okay, this becomes wz plus 32i minus 240 over wz. Okay, this is the LHS. Now let's just simplify the RHS. That's 5 plus I times negative 4 plus 10i. And then that's negative 20 plus 50i minus 4i minus 10. So negative 30 plus 46i. Okay, so now what can we do? 30 wz. Okay, let's just bring the 32i to another side so we get something in terms of wz's only. Minus 240 over wz, and then this will be equal to negative 30 plus 14i. Great, and then now what we can do is we can get a common denominator, and then once we get a common denominator and multiply through by wz, this will have a wz in it. We can bring it to the other side and we'll have a quadratic. If that's too quick for you, we'll just do it in steps. So wz squared minus 240 is equal to negative 30 plus 14i times wz, right? And then now what we can do is we can bring this to the other side. Bringing it to the other side, we get 30 wz squared plus 30 minus 14i wz minus 240 is equal to 0. Now we have a quadratic in terms of wz. We can we can easily find this. Well, not easily, there's a bunch of calculations we have to do, but let's just get started with it. So applying the quadratic formula, we get wz is equal to 14i minus 30 plus or minus the square root of this squared, that's 900 minus 840i, 900 minus 840i, and then that becomes 196i squared, so negative 196. Simplifying that gives us 704. 704 minus 840i, and then minus plus, so that becomes 960 plus 960, and then over 2. Just make sure I did that correctly. 96 negative 196 for 200 looks good. Alright, so combining these two things, we get 14i minus 30 plus or minus square root of 64 minus 840i over 2. Now nothing good can be done unless we find the square root of this. So we have to find what the square root of 1664 minus 840i is. So if we set this equal to a plus bi and square both sides, we get a squared plus 2abi minus b squared is equal to 1664 minus 840i, and then we have a squared minus b squared is equal to 1664, and then 2ab is equal to negative 840 by simply matching the real and imaginary parts. Okay, we can substitute that b is equal to negative 420 by a into this to get a squared minus 420 squared over a squared, my god, okay, a squared is equal to 1664. That's good. And then now what we can do is we can multiply by a squared and bring this to the other side to get a to the fourth minus 1664 a squared, a fourth minus 420 squared, 420 squared, and then this will be equal to 0. 420 squared, a to the fourth minus, okay, that looks good. Now what we have to do is we have to solve this quadratic. Now this is the AIME, so it will have some computational problems, but chances are this quadratic will factor nicely. So let's just calculate 420 squared. This will be 0, 0, 0, 0, 0, 4, 8, 0, 0, 0, 8, 16, and then that gives us 0, 0, 4, 16, 17, 176,400. 176,400, and now we can immediately see how this factors. This will factors as follows: a squared minus 1764 times a squared plus 100. Great. Now what we do is a cannot be imaginary, therefore this is not possible. Therefore a squared is equal to 1764. So that means a will have to be equal to 42. A is actually equal to plus or minus 42, and then if a is equal to plus or minus 42, b is equal to, we go back over here, if a is equal to plus or minus 42, b is equal to plus or minus 10. Wait, hold on. So 84, 10, or 10. B is equal to 10. Yeah, plus or minus 10, I'm correct. So we have a is equal to 42. So we have the two possible complex numbers are 42 minus 10i, or we can also have negative 42 plus 10i. So these are our two possible complex numbers. So now we have to plug this into this thing. So plugging it into this quadratic, this gives us 42 minus 10i. It doesn't actually matter what we take. Since there's no concept of a principal root when dealing with complex numbers, we can actually take either one and we'll get the exact same answer. And to see that, it's not super hard. So we actually have 14i. Let's divide the 2 into it to get 7i minus 15. And then this becomes plus or minus. This becomes 21 minus 5i. Okay, and then doing this will give us, we have 7i minus 36. If we take the plus, we get 7i, 6, 2i plus 6. And if we take the minus, we get negative 36 plus 12i. This will obviously give us the smallest magnitude. So the magnitude will be root 40, squaring that will get 40. And we are done.